And I'm waiting for the notification. There we go. And I'm going to go to the participants list. I'm going to take some screenshots just in case I forget to take attendance later. And I'm going to try, like anything, not to forget to do that, but you never know. Lots to think about. Okay, so let's get started. So I want to talk about a few things, one of which is I've had students say to me, well, I've missed like a month of school because of this or this or this. And I'm thinking to myself, well, what do I tell them? And what I tell them is this. So this semester is the first semester that the ALEKS folks have come up with a way to have open pie mode in an ALEKS course with objectives. So I want to talk about that. So if you complete a homework objective early, for instance, our current objective is due this Thursday night at 11 p.m. It is Intro to Functions. So Intro to Functions is due at this Thursday at 11:59 p.m. The date is 9/17. So let's say you completed that objective early. What would that mean? Say you complete that objective tonight. What would that mean? Well, if you completed that objective tonight, you would have completed it before it was due. What happens if you do that? If you complete an objective early? Well, you have two options. The two options are you can go back and work on past due objectives and get caught up with those, get more credit for those, so you do better in the class and are more ready for the first test. So you likely will do better on the first test too. So that's one option. Let's say you have got 100% on all of your objectives so far. Then you can work ahead in the course if that's the case. But this is a great way to get caught up. So if you complete a homework assignment, objective early, like say tonight, you enter into open pie mode. This means that you are allowed to work ahead or go back to previous homework objectives. I would encourage you to go back to previous homework objectives first. If you're all caught up with everything, feel free to work forward in the course and do future objectives. That's why the way the course is set up is really nice, because you can go back and forth like that. So this means, let me read this again. This means that you are allowed to work ahead or go back to previous homework objectives until the current due date is reached. So at 11:59 p.m. this Thursday, Intro to Functions is due. And so what happens then is right at the moment it's due, the next objective, which is more on functions, is going to open up. So at that moment in time, you will no longer be able to work on past due objectives that you didn't, for which you didn't get 100% on. You will then need to work on the new current objective before you can go back and get all of those topics correct before you can go back and work on any previous objectives. An alert will appear on your ALEKS homepage stating how many days you have left to work ahead. So you will see an alert that looks similar to this. This up here is not from our course. This is something the ALEKS folks sent me recently because I asked them if they could clarify or if they had any documentation I could present to my students. So this isn't from our course. Whoops. This isn't from our course right here. But I have seen this when I have done various things in the student view of ALEKS. Objectives unlocked. You've got so many days left. So this is the time you want to look for this kind of notification, and this is the time that you want to get caught back up, or you have the chance to go back and work on past due objectives if you have any topics remaining that you need to finish. So once the current due date passes, the next homework objective will open, and all other homework objectives will again be locked, except for that new current objective. So let me ask you, do you have any questions at this point? Let me go back in. Let's see if anybody has questions. Let's go into the conversation. Luke, we can talk offline about that, okay? You talk offline, please send me an email with that in there, and we can talk via email about that, okay? I want to make sure I'm covering. I will ask for all kinds of questions on Thursday about the test. So yeah, so Luke, please send me an email on that, please. That would be great. Yes, you're right, Luke. I'm reading ahead now. Okay, good. Okay, so anybody have any questions about how the ALEKS objectives work and how you can, if you've completed the current objective before its objective due date and time, you can go back and work on previous objectives to get caught back up with the course. And I had a student in my last class comment, well, I'm behind. So how am I going to understand what we're doing now? And I said, well, we talked about solving equations, and now we're talking about functions. They're really two different types of they're two different chunks of material. They're not that related. And also so I would encourage you to get the current objective done as fast as possible, and that way you can go back and work in chapter 1. So, or among those first objectives that we did. So anyway, no questions on that. So let's take a look at, I want to look at something in ALEKS now. Let's take a look at that. If you ever can't see my screen, make sure you give me a shout out. I don't want to spend time and having you sit there not being able to see what I'm talking about. So let me go to this screen. I want to talk about, first of all, the Intro to Functions objective is due this Thursday. We talked about that last time. We are going to talk about more on functions today. That's due this Sunday. And then there's a test 1 review objective coming up that's due next Wednesday, the night before your test. Let me just talk about that test 1 review objective for a moment. So I want to go over here to take a look at a report from this class. You won't see any of your names. So I can go and I can look at a report from this class to see how my students are doing. Let's look at test 1 review. Now you may look at this and say, gee, there's an awful lot of topics in this. That's true, there are 25 topics in this review objective, but they're all topics that have been in the course up before. These are all topics that students have seen before or should have seen before. So, and you will notice squaring a binomial univariate. 100% of you have credit for that, either through a knowledge check or because you did the topics in ALEKS. And you're seeing some pretty high numbers, 87%, 83%, 87%. You're seeing some relatively low numbers. We are actually, this 22%, we're going to talk about that today. So this 9%, I believe that is in a the objective that's due on Thursday. So maybe not too many people have worked on that. This right here, domain of a rational function interval notation, we're going to talk about that today. So domain of a square root function, advanced, we're talking about that today. And so you can see that really my point in showing you this, and as a class, you have 50% credit for all of these topics already, some of which you haven't even done the objectives on. So it really isn't as bad as it looks. Every single topic in this objective is one has appeared somewhere else in the objectives before it. So I did want to point that out. So any questions on what I just talked about there? So now what I want to do is I want to go between Alex and the whiteboard, and I want to talk about graphing in Alex. We're looking at the more on functions objective today, and I want to start by looking at 3 graphing topics. I want to show you how to graph in Alex, and we're going to be using the graphing calculator quite a bit today. So if you don't have yours right in front of you, you may want to just go quickly and grab it. So let's start by going into Alex and looking at a problem. So I'm going to go back into Alex here. I'm going to go over to the class tools here. I'm going to go into student view. And let me just check what course this is. Okay, enter student view. And I am going to, I have a way of doing student view so I can literally get to any topic I want at any time I want. So I'm going to click on this right here. That will take me up to the carousel. And the carousel are these cards here that you can go back and forth. So Alex calls this a carousel. And I want to actually go into our more on functions objective. And what I'm looking for is I want to look at graphing a cubic function. Right here. So I would encourage you to write this down. I really want to find one that has a negative sign in front. So I'm going to see if I can find us one. That doesn't. I don't want to spend a lot of time looking for one. That has one. So let's graph this function in Alex, and we're going to go to the whiteboard to help us. So I'm going to copy down the function y equals negative. This 3 over 2 I'm going to put in parentheses by itself. I want the negative sign outside of it. And then x cubed at the end. So let's read the directions that Alex has for us. Plot 5 points on the graph of the function, 1 point with x equals 0. So I'm going to draw an XY table. And the first column is going to be the x, second column is going to be the y, and for the first x, I'm going to put in 0 because Alex wants us to use x equals 0. So I'm going to put 0 in the x column. And then 2 points with negative x values. So that would be -1 and -2. And then 2 points with positive x values. That would be 1 and 2. And we want to fill out this t-table. So I'm going to go back to back to Teams, lots of terminology here. And what I want to do now is unshare so I can share the whiteboard. Now, the recording does not record the whiteboard. So you might want to take a screenshot of the whiteboard. So I am going to share the whiteboard. So probably want to use your graphing calculators because you'll get the most out of this if you do. And I want to write, let's write in green. Our function that we are wanting to graph is y equals negative 3/2. Oops, got a little carried away there. 3/2 x cubed, like that. It's exactly what we want to graph, and we want to make a t-table. So here's our t-table. Hard to get down further than that. I might have to extend it in a moment. But our axis, this is our x column. This is our y column. In our x column, we have 0. We've got -1. We've got -2. We've got 1, and we've got 2. We want to know what those corresponding y's are. So how do we do this? We want to take this function and put it in y1 of our calculator. So this guy we want to put in y1 of our calculator. Y1 equals, you want the y1 equals key. You want this key. Oops. If I click too soon, I get myself in trouble. So you want this key on your calculator. That's what you're looking for. That is, it's actually doesn't have the blue on it. Doesn't have the blue on it. You're looking for that key. Okay, and then I'm going to circle this. This is the key you're looking for. Y equals, it's in the top row. First button it's the first button in the first column and the first button in the top row. You want y equals. So if you click on that button, and if you have any questions about the calculator, please let me know. You can't get off a screen or something like that. Please don't give me a shout out on that. I don't want anything holding you back. So the first button I'm going to click. Oh, yes? Yeah.
Okay, so I had to run upstairs and get my calculator. Oh, you know what? I just found it.
Okay.
Never mind.
Okay. Cool. I'm glad you're using your calculator. So you want to click on y equals. I'm going to clear out what's there because something is there. And I'm going to type in the negative button in the bottom row. We don't want minus sign. We want the negative sign that's in the bottom, very bottom of the calculator. It's got parenthesis, negative, parenthesis. That's what we want. And then a parenthesis. With those parentheses are in the middle of the calculator, really. So I want an opening parenthesis, 3 divided by 2, parenthesis. And then I want an X. So there's a button, the X button. So where do we get the X? So you want to get the X. The X button, there's a button, it's in the second column. Columns go down, second columns, third button down. It starts with an X, comma, T, comma, theta, comma, N. That, you want that X. So I'm going to click on that button, give myself an X. And how do we get this cube? So we go to the, lots of times if you don't know where to go in this class, try the math button. So I want math, the math button. So that doesn't look like, it looks more like an O. So I want the math button. So to go to the math button, that's in the first column. Click on the math button. And then if you look down, there's convert to a fraction, convert to a decimal, then there's a 3, and in option 3, there's a 3 high up. That is what we want. So you want to go to the math button and select option 3. Okay, so you want to scroll down and select option 3. I wonder if I don't think I've ever tried pressing just the 3. Oh, just press the number 3. Works. Can't blame a girl for trying. So, all right. So that's what I have on my calculator now is negative 3 halves in parentheses, the 3 halves in parentheses, x cubed. Anybody have any questions on that so far? Okay, so the next place I want us to go is to table setup. So what you want to do is you want to get to table setup. You want to click on the second key. So this key right here, it's in the first column, followed by the window key in the top row of buttons. Oops. So we've got this second window. So I'm going to do second window. And the way you want this to look like is you want to see a 0, a 1 going down. There's like there's 4 different options you can have here, or 4 different options you can change. So you want 0, 1, auto going down. And then you want to go to the table of the calculator. So how do we get to table? Table's above the graph key. So we need to do a second. And then we need to do graph. So second button, followed by graph. So keep in mind, unfortunately, Microsoft doesn't record the whiteboard. I wish they did. It would make life a lot easier.
Ms. Bear?
Yes?
I'm actually using VidGrid to do the whiteboard.
So this one is built in, and I have so many things that are out and about that I'm using anyway, and I don't want to have so many things because otherwise it's so much to keep track of, if that makes sense.
It does, but I don't.
So, yeah, I know. So you want to go to second graph now. So second graph. So on the test, you're only allowed a graphing calculator or a scientific calculator. You're not allowed any many resources at all. You're not allowed a formula sheet. You're not allowed your notes. You're really allowed a graphing calculator and a pencil and paper, and that's really it. So you're allowed, you could use a scientific calculator, but I'm not sure that would help you very much. So second graph, if I click on second graph now, it takes me to the T table of the calculator. So now we just want to fill in. Now I will make one comment about Alex. They want every X, Y ordered pair you enter to be exact. They only want exact answers. They don't allow, Alex doesn't allow rounding very often. It may be in an application problem, but not in graphing. They want the graphing to be precise. So who can tell me what the Y, when X is 0, what is the Y coordinate? You see it on your calculator? So if you go to X equals 0 and right arrow over, what do you see in the Y column?
0.
Exactly, 0. 0. Who wants to tell me what we see when we go to so if we go back to the X column and we go backwards to see -1, what's in the Y column? What's in the Y column?
1.5.
Exactly, 1.5. Let me make sure that I see that when we go back to Alex. Okay, I'm going to go back to the X column and go back one more to -2. What's in the Y column? Can somebody else tell me what's in the Y column? Well, somebody who's already spoken before, what's in the Y column?
Oh, for -2, the Y is 12.
Exactly. Shows me you're participating. So that's good. Okay, now let's go to the X column and go forward past 0. What's the Y value that corresponds to 1?
-1.5.
Yes, -1.5. Good. And what about what's the Y value that corresponds to X equals 2? Anybody?
-12.
Yes, -12, exactly. You match mine perfectly, it sounds like. So that's what I got. So I've got 0, 1.5, 12, -1.5, and -12. So we've got a 0, 2 positives, and then we've got 2 negatives. Okay, let's go back to Alex. I'm going to take a screenshot of this whiteboard because I'm going to have to reshare my screen. I wish Alex had those screens together, and it would be nice if I had another whiteboard. I'm going around Alex and Canvas and, but this is not bad. It's just not perfect. So let me reshare my screen. So let's go up back to Alex. And here we are. Can somebody say that they see the Alex screen now?
I see it.
Thank you. So let's take a look. We want to graph our function now. So let's take a look at this important tool that's got 4 quadrants on it. Alex calls this a plot a point anywhere. And they even tell us, warning, do not approximate. For example, write 1/3 and not 0.33. So they want the exact answer, not rounding, no rounding involved. So we just go down our t-table. First point is 0, 0. Plot point. Next point, -1, 1.5. Okay, plot. Next point, -2, 12. Plot. Next point, 1, negative 1.5. And last point, 2, negative 12. Plot. Now, after you see one of these, you will have an idea of what these graphs look like. You might want to keep that in mind because it may help you identify whether you've made an error early rather than later. So I've got 5 points. We were asked to plot 5 points. I'm going to X out of this, and then I'm going to use this curve tool right here. And that looks good. And I'm going to check. Any questions on this? So this gives you a very good idea how ALEKS graphing works in general. You make a mistake, this is an eraser. This is a pencil. You can plot points, but you really have to be very careful and make sure you plot the point with the absolute correct X and the absolute correct Y. That's why I prefer to use this tool here. I just type in the coordinates. I find that easier and more exact. So let me see what I want to look at next. We looked at this one. So that's done. Let's look at graphing an absolute value equation. Let's go back up into the carousel. I see it right here. And start. Now let's find one with a negative out front, make it a little difficult. More so we do look at one of those. There's a negative out there. Let's look at this one. So now the way you plot these is you always want to choose. They don't tell you this. They might tell us this when we look at the explanation page. You always want to choose X equals 0 for sure. And I believe you could get away with -1 and 1 all the time. I think, I can't see every ALEKS question for this problem, but they're looking for only 3 X's, 0 for sure, -1 and 1. So just start by trying that for all of the problems. I think you can do all of them at least that way, at least the ones I've seen in ALEKS, but I don't have a crystal ball and they have so many questions for each topic. I don't even have a way to look at them if I wanted to. So RY in this case in a t-table is negative absolute value of X. So absolute value function is a distance. It's the distance between whatever number is in here and the origin. How many steps would it take to get you to the origin? That's really what it is. And if it's how many steps, it's 0 if you're staying put. If you're on the origin and if you take the absolute value of 0, what's the distance between if you had 0 in here, these represent the distance. What's the distance between 0 and 0? 0. And then -0 is still 0. So the y. So if you want to find the y coordinate, it's 0. So absolute value signs just mean what's the distance between what's in here and 0 on the X number line. So if you have 0 inside, the distance between 0 and 0 is 0. -0 is 0. So our first y is just 0. I'm just looking at my calculator real quickly here. See if I can remember where the absolute value is. Yes. So if you really want to, you want to know where the absolute value is, let me show you how to get there. Let me tell you how to get there. And remind me, and when I come back to the whiteboard, I'm going to do another whiteboard. I've written down a note to remind myself to show you. Okay, so the first point we have in our t-table is 0, 0, the x and y coordinates. The next one, we put in -1 here. We're at -1 on the number line. How many steps do we have to take to get to 0 if we're at -1? How many steps do we need to take to get to 0 if we're at -1? And each step is like 1 unit. So if I'm at -1, I need to take one step to get to 0. So the absolute value of -1 is 1. So we just took the negative sign and took the negative and made it positive. Okay, so now we're at +1. But what if now I have to take the negative of that because the negative's on the outside. So I actually get -1. Now, what about 1? Let's put 1 in here. What's the distance between 1 and the number 0? How many steps do I have to go from 1 to 0, backwards to 0? 1 step. So the absolute value of 1 is 1. And then I just have to change the sign and get -1. And that would be my y corresponding to the number 1. Okay. So all we have to do is now plot these 3 points, but the way we are going to graph it is a bit different. So I'm going to go to my Plot Anywhere tool. And this time I'm going to put in 0, 0, plot. Then I'm going to put in -1, -1, plot. And then I'm going to put in 1, -1, plot. And you will see, if you imagine drawing a line ray this way, and you imagine drawing a ray this way, it's going to be a V-shaped graph. You X out of this. And for absolute value, you want to use this tool here, this ray tool. Means it has an endpoint, this right up here means it has an endpoint here, and it goes forever in one direction. So that's the ray tool. So I'm going to click on this, and you can see it's really telling me, it's guiding me almost. So let's go back here. I'm going to click on the bottom, what's going to be the top of the V, top of the upside down V, and then I'm going to click on this other point. I'm going to make sure that this little red X I see is right over that blue point, and click. Then I'm going to go grab this again. I'm going to click on 0, 0 here, the top of the upside down V, and then I'm going to click on this point here and make sure there's a red X over that blue dot. And that's what I get. And absolute value graphs are V-shaped graphs, just like what we saw with the cubic last time. If you can visualize what that looked like, it's good to know what different kinds of graphs look like to give you assurance that you've got the correct graph. So I'm going to check. And it's correct. So does anybody have any questions on this absolute value graph that I just drew? Any questions before we move on? So let me just cross that one off the list. Let's look at another graphing problem. So I'm going to go back to the carousel, and this time I'm looking at a graphing a square root function. This one, problem type 1. So let me see what other one I can find. In my mind, let's look at this one. So let's write down the function because we're going to go into ALEC, use the whiteboard for this one. So we want to plot the leftmost point and 3 additional points. So we're going to figure out how to choose those X and Y. What does leftmost point mean? So let's go back to Alex. Not Alex, go back to Teams. Got to think about what I'm saying. So let's take a look. I now want to unshare my screen and share the whiteboard again. We'll see what happens with that. It may give me the same thing back, and it does. I wonder if there's a way I can deal with it. I'll see if I can deal with that over there. Yeah, I'm not sure I want to do that. So let's see what happens when I try to draw my function. Okay, that looks good. So my function, f of x, is equal to square root of x plus 4. So that's our function. The first thing that we need to do is determine the leftmost point. How do we determine the leftmost point? We take what's inside the square root, and this works for every one of these problems. We take what's inside the square root, which is x plus 4,
I'm only seeing what we did last time. I'm not seeing what you're writing on the whiteboard now. I see what we did last time.
Oh, let me make sure that this, I thought I was sharing the whiteboard. Thank you for speaking up. So what do you see now? Just what we saw last time?
Well, now I'm not seeing the whiteboard. Oh, wait.
I see the whiteboard, but it's like the last problem and the current problem.
I see the last
problem.
problem.
The current problem, but it's okay. The last problem is over to the side. Can you just see the current problem? You see the current problem, f of x equals square root of x plus 4?
No, I was seeing the last problem, but it's loading now. Okay, now I see it.
Okay. Okay, you all see it now? Yeah, I know the other one's off to the side. I'm sorry about that. It doesn't really have a good way to get to another whiteboard really fast. The software is not that great. So do you see the f of x equals square root of x plus 4 over here?
I see it.
Okay. So what we want to do, one of the directions and Alex wants us to do, find the leftmost point. So you find the leftmost point the same way for all the questions in this topic. There are only when we graph, we're only graphing in the real number system in this course. So if let me just write this out first. So what you want to take is this radicand, which is what's inside the square root, make it positive. Whoops. Make it positive, which means greater than 0. We can take the square root of positive numbers, or we can take the square root of 0. So I can take, for instance, the square root of 4, which is a positive number, and it is 2. I can also take the square root of 0. It's 0. So we can only take the square root of positive numbers, which means whatever this represents has to be bigger than 0. We can also take the square root of 0, which is what this number here is. Let's say it's 0. It's possible for this to be 0. It's possible for what's inside to be 0. And if we took the square root of that, we're allowed to, and the square root of 0 is 0. So my point is, we can take the square root of any numbers, which right now we have this representation for a number of numbers which are bigger than 0, which is positive, and also we can take the square root of numbers which are equal to 0. We can't, however, take the square root of, say, a negative number, say -1. What's the square root of -1? Can somebody tell me? I. Very good. And I is an imaginary number. It's imaginary unit. It's a complex number, which is not real. We're only graphing in the real number system. That's why we don't want to include the negative numbers here. We're only graphing in the real number system. So I'm just going to get rid of that. I just wanted to talk about that. So we want to solve this little inequality. One thing about inequalities, if you multiply or divide by a negative number, you need to switch the direction of the inequality symbol. So I would avoid that. And I think for the problems you're going to see in this particular topic, you can avoid that. So we want to solve for x here. So how do we solve for x here? It's so sensitive. Okay, how do we solve for x here? The opposite of adding 4 is subtracting 4. So these cancel. 4 minus 4 is 0, x plus 0 is x. And on this side, greater than or equal to 0 plus a -4 is -4. Now remember, Alex mentioned leftmost point. If you're coming in from negative infinity, the leftmost point's going to be the smallest point. So let's turn this around and write this as -4. The big mouth points towards the x, so I'm going to have that like this. This is the leftmost point that Alex is talking about. That's the leftmost point that Alex is talking about. -4. So we want to start our t-table with x being -4. And then we're going to pick bigger x's after that. We want 3 additional points. Now it's not so easy to tell what those 3 additional points are going to be. We really need to use our calculators to do this. And we've used the process already to do this with the first topic that we looked at today. So the first thing I'm going to do is go into y equals. Click on the y equals button. That's the button at the top of the first column, and it starts the first row on the calculator, y equals. I'm going to go over to the clear button on the right side of the calculator, and I'm just going to clear what's there. out of there quickly. Now, last time we looked at how to get the square root on the calculator. The square root is above the x squared key in the first column. So the way that we get that square root, which is above a button, is we press the second key in that column and then x squared. That will open up the square root. It will just give me a square root sign, and then I can type whatever I want inside the square root. In this case, x plus 4. And then I'm ready now to go to the table. We have the table set pretty the way we want it. So I want to go to the table. That is second graph. And I want to go back in the x column to -4 just to see that I got what I got for that. You notice if I put -4 in here, I get -4 plus 4, which is 0. Square root of 0 is 0. So I know, I'm confident I entered it in my calculator correctly. So this is the y column. So what I would say that you want to do at this point is Alex wants everything exact. The chances are that if your number reaches the next, there are black lines making columns. If your number in the y column is really close to both black lines in the y column, chances are the calculator is rounding. So you want to make something you want to only put ordered pairs in your t-table that you are sure that are exact. So the next one I see going back is -3, 1. I'm sure that that's exact. And then I go back in the x column. I see 1.4142. That looks like it's quite possibly rounded. I go back to -1, same thing. I go to 0. So when x is 0, y is 2. And now I believe we need 3 more, so we need 1 more because we've already, or I believe we need 3 additional. So with the leftmost point being 1 and the 3 additional, we need a total of 4. So let's go. The next number I see that I'm going to use is 5, 3. So that's what I got. Does anybody have any questions on our t-table there? Well, I copy this down so we can go to Alex. So -4, 0, -3, 1, 0, 2, and 5, 3.
I have a quick question.
Yes.
So did you put that in the calculator to get those? I'm just a little confused about that part.
Okay, so what part of putting something in the calculator do you not understand? What's the first place? Because I don't know how far to back up.
Oh no, I understand. Like, how did you put it in the calculator? Like for the plot, I guess. Like, so y equals. Did you put it in that and then you plotted it and got the table? Like, what numbers did you put in, if that makes any sense?
Well, the table automatically populates numbers. Okay, so I didn't put anything in the table. The table automatically, the way we have our table set by what we did with the first whiteboard, automatically kept those parameters, what we had set it to, and it automatically populated.
Yes, I get that. I'm just saying, what did you put in the calculator to get those numbers on the table?
This square root of x plus 4. So this would go in y1 right here.
Okay, awesome. Thank you. Sorry, I was just a little confused there.
Do you now know where to put it?
Oh yeah, I know where to put it in and
Okay,
everything. I was
so
just
this one goes into, you want to use the y equal.
yes, awesome. Thank you.
That's good. I'm glad we figured that out, because that's a simple answer to that, right? I mean,
Yeah,
know
I guess I just got
there.
a little confused on what to put in there. So thank you
Yeah,
very
well, you
much.
know, I get that, because you have a lot of things you're thinking about, right?
Yes.
So everybody good? Any other questions? Thank you so much for your questions. It's very good, because maybe somebody else had that same question. Everybody good? Anybody have any questions? I wouldn't be spending so much time on the graphing if I didn't think it was very important. So that's why I'm spending a lot of time on the graphing. And I can put these screenshots of the whiteboards in Canvas. When I've got down my list of things to do, as soon as I can get those in there. Okay, everybody good with the whiteboard now? Okay, and you've even got this one. I know it's small, but you can kind of see it too. So let's go back to Alex now. Now, this is tricky, because I have to unshare the whiteboard and go back to sharing my desktop again. And I see the red border, so I think I'm okay. If I'm not okay and you can't see what I'm doing, please, please don't hesitate to ask, because I want to know. Can everybody see? Somebody tell me whether they can see the Alex screen now.
I can.
Thank you.
I can.
Okay, so we've got 4 ordered pairs we need to plot. So we're going to go right to the plot a point anywhere tool. First one, -4, 0. That would be right. I'm just checking it in the square root notate function really quickly. Okay, so you see that over here at -4, 0 on the graph, -3, 1, -3, 1. So -3, yep. So that makes sense. So plot that point. When I click on plot point, it'll take the numbers out of here. So 0, 2. So if I put in 0, I will get square root of 4, which is 2. I'm just doing it in my head as we go. 5, 3. So 5 in for x plus 4 is 9. Square root of 9 is 3. Okay, so we've got all of our 4 points. Oh, that took it off. I had no idea that would take it off. Let me put that last point in again. 5, 3. Plot. Okay, so we have 4 points on our graph, and we've hit plot point after each of them. So let's X out of here. Let's go to this curve tool. And that looks like the top half of a parabola that's opening sideways. So that's what typically a square root graph looks like, just to tell you. So let's check this and see if we get it correct. I think that chances are very high if we got a graph that looked like that. Any questions at all on graphing in Alex? Go back to Teams here. Oh, there. That's where it is. Any questions at all on that? So let me go to some other topics I want to talk about today, but they're not graphing topics. Let's go to this document. Now we just finished graphing a function which was a square root function. So we have an idea of what this, if we were to graph this, we'd have an idea of what the graph would look like. But we're asked to find the domain of a square root function. The domain is the set of all x values for which the square root makes sense. And you could see, you know, back in the calculator, if we go backwards, we're seeing some, if we go back like to where -5, -6, -7, -8, and so forth, we're seeing error. We're seeing error because those square roots don't exist in the real number system. They involve an imaginary unit. So this is really related to what we just did. We want to find the domain of this square root function. So we're looking for all of the x values for which this square root makes sense. And we see from our calculators that we got errors for a bunch of them. So we know this square root is not going to exist for all real numbers. There's going to come a point where you will be taking the square root of a -1, really, and that would be the imaginary unit. And we don't have that in the real number system. So the way we do this is very similar to what we just did, in a sense. We want to know which kinds of numbers can we take the square root of. So this 8 minus 2x is called the radicand. What's inside the radical is called the radicand. It doesn't involve the square root sign. It's just what's inside. So we know that we can take the square root of numbers, this radicand here, which are positive or equal to 0. So remember, this right here, let me see if this will work for me. This right here, maybe I should write it better. That's the square root. And let's see if I can get this to work by doing that. This is really greater than here. This is the top bar of, like an equal sign has 2 horizontal bars. This is the top bar of an equal sign. So we can take the square root of a number which is positive, or if this turned out to be 0, we can take the square root of 0. You can try it out on your calculator. So if you're on your table, in your table, and you want to get back to the home screen, you can just hit the second button and then the button right next door to the second button, which is the mode, and you will get back to the home screen. If I wanted to find the square root of 0, I could do a second x squared. We've talked about this. Put in 0, enter, and I get out 0. So it's possible to take the square root of 0. So we can take the square root of positive numbers, and we can take the square root of 0. That's the reason for the greater than or equal to sign here. So in this situation, this particular problem, I took the radicand and say, okay, I don't know what number is inside here. I'm just going to copy it down the expression, but I know whatever number it is, it has to either be positive, bigger than 0, or equal to 0, because I can't take the square root of a negative number. So let's figure out, by solving for x, what our domain is. When we were asked to find the domain, we want to know for what x's can we actually find the square root of this. For which x's? Domain is an x concept. So let's solve this for x. The opposite of subtracting 2x is adding 2x. Do it to both sides of an inequality. And remember, you want to avoid multiplying or dividing by a negative number. Otherwise, you would switch the direction of this inequality symbol. And you really should be able to get away without doing that. So I want you just to keep that in mind from past math courses. So adding 2x to both sides. These cancel, we're just left with 8 greater than or equal to 0 plus 2x is 2x. To get x by itself, we need to undo multiplication by 2. The opposite is division by 2, so I divided both sides by 2. 8 divided by 2 is 4. 2 divided by 2 is 1 times x. Is it just x? Now I'm going to turn this around and write it from smallest to largest, because that's how we write interval notation, which we'll talk about in a bit. So not multiplying or both sides by anything, I'm just writing it the other direction. So this is 4. We've got the big mouth going towards the 4, so we're going to still have the big mouth going to the 4 over here. And this little v here, part of the inequality, it's still pointing to the x. It's still pointing to the x over here. This allows me to write our answer in interval notation. So in college algebra and above, we generally write our answers using interval notation. So I want to plot this on the number line. So this says any x is in the domain which is smaller than 4 or equal to 4. That means all these numbers from negative infinity to 4 and equal to 4, which means we color in the dot at 4. So to give you an idea of how we do our interval notation, you might want to take down these notes in purple here, because I just put this in this morning. And I'm like, I want this in the class for today, but I don't have time to rescan everything. So I put it in. With interval notation, you want to use parentheses when you have a negative infinity or positive infinity, or the endpoint is not included. Or you could also look at that as there's an open circle at that particular point. When do we use brackets? When the endpoint is included, or we want the point, or we have a colored endpoint. So in this case, what do we have? We have negative infinity. Now negative infinity out here, we use a parenthesis with it. It's in the parenthesis column. So negative infinity has a parenthesis going in this direction because we're going in from left to right. So we want all the points from negative infinity, all the x's from negative infinity, all the way that this comma means all the numbers in between negative infinity and 0. And we want 0. Why do we want 0? Because that endpoint is included by virtue of the fact that it's colored in. So that's the reason why we use a bracket, and we want to end it there. So we want it to face the negative infinity. So we do it that way. So any questions on this particular problem? Yeah, that's good. Oh, we need this one. I was doing the other one, but that's okay. I'm sorry about that. What about this one's done exactly the same way? We're coming in from negative infinity. We put parentheses around negative infinity, and we want all the numbers between negative infinity and 4. We want 4 is colored in, so we use a bracket because this endpoint is included. Same thing. Let's do another one in this topic, and I'm not going to do it all the way. Maybe I will. But what are we concerned with? We want to find the domain of the function. Domain is concerned about x's, and what the problem with this is potentially is this square root. You can't take the square root of each and every real number and have it be a real number. The square root of a -5, it's going to be a complex number that is not real. So we can't do it for each and every number. So same thing, same process. Take the radicand, which is -x, and make it greater than or equal to 0. Take whatever's inside the square root, in this case -x, copy it over, and make it greater than or equal to 0. Now this one you want to be very, very careful of. You want to be careful of that you don't want to have to multiply or divide by a negative number unless you really are comfortable with doing so. So rather than multiplying by a negative number, I'm going to, this is negative x. The opposite is adding x. You can think of this as subtracting x. I'm going to add x. So I'm going to add x to both sides. Negative x plus x is 0. Greater than or equal to 0 plus x is x. I'm going to turn this around and write it from smallest to largest because that's exactly how we do interval notation. So this v here is pointing towards the x. If I put the x on this side, I still want the v to point towards it. And then I want the big mouth to open up to this 0. So this big mouth over here opens up to the 0 this way. And of course, we have equals is equals. And now we just talked about this a moment ago. Same thing, coming in from negative infinity, always use a parenthesis with negative infinity. All the numbers in between, 0, it's colored in. The endpoint is included. Colored in, if the endpoint's included, we want to use a bracket and we want the bracket facing the negative infinity. Any questions on this particular topic? So let's look at the next one, having to do with finding the domain of rational functions. Just getting all organized here. There we go. So what do we have to watch out for when we're talking about rational functions? We've got x's in the denominator in both of these. We cannot divide by 0. So I want everyone who has their calculator with them to take their favorite number, type it in the calculator, and use the division sign, and then put 0 in the denominator, and do enter. What did you get? What do you get?
Error.
You get an error. And the error on my calculator says, error, divide by 0. Division by 0 is undefined. So what we want to watch out for in the last problem, in the last topic, we wanted to watch out for taking the square roots of negative numbers. Here we're watching out for division by 0. So we want to look at this denominator and say, for what x's is this denominator 0? What x's is this entire denominator 0? And then we need to throw out those x's. Okay? And we're only concerned about x's, which are real numbers, by the way. Because when we talk about domain and range, they are graphing topics, and we're only graphing in the real number system. So division by 0 is undefined. So we want to take this denominator, we want to set it equal to 0, and we want to find the x's that are going to cause division by 0. So our denominator, our entire denominator is x squared plus 3x minus 40 equals 0 right here. Now, I'm not going to spend time talking about the factoring, but if you factor this, this is what you get. We can check by foiling. X squared, check. X times negative 5 is negative 5x plus 8x. That's plus 3x, check. 8 times negative 5 is negative. 8 times 5 is 40, equals 0. And how do we solve this for x? So we have a product of these two equals 0. So the only way we can get, and this means a real number here, this means a real number here. The only way we can multiply two real numbers together and get 0 is if one of them is 0. So x plus 8 is 0 if we move the 8 to the other side when x is equal to negative 8. This number is 0 when x is minus 5 is equal to 0. If we move that negative 5 to the other side, it will go over to the other side with the opposite sign. We get x equals 5. These are the two x's, negative 8 and 5, that when we plug them into the denominator and do their calculations, we're going to get 0 in the denominator. So we want to take these two numbers, negative, well, these two numbers, negative 8 and 5, cause division by 0. So we want to throw them out. All the other numbers are fine. So we start at negative infinity. Want to make sure you have these numbers written from smallest to largest, so you don't throw out 5 before negative 8 on the number line. That wouldn't be, that's not how our number line works. So we want to make sure that we start it. We want all the numbers from negative infinity. The first one we're going to throw out from left to right is negative 8. So we want all these numbers till we get to negative 8. We're going to put an open circle here to indicate that we do not want the number 8. We only color in things, including these lines here, when we want points. So we don't want to color this in and make it look black, because that would definitely suggest we want the negative 8. We do not want it. So we want an open circle here. And then we want all the numbers a hair after that, all the way to 5. 5 is going to cause division by 0. So we want to throw out 5, and we do that by writing down 5 with an open circle above it. Then we want to start just a hair beyond, starting up again, a hair beyond 5, and keep going forever and ever and ever and ever. So how do we write this? Well, we start at the left. Negative infinity has parentheses around it. And we want all numbers between negative infinity and negative 8. An open circle means a parenthesis by that little chart that I wrote down. And I hope you copied that down. And then we're going to take a break for a small amount of time. So we write union. It even reminds us to use a U for union here. Union. We write union in between. U for union. And then we start up again a hair beyond negative 8 and go to a hair before 5. And we want all these numbers in between, and that's what that comma denotes. And then we start up a hair beyond 5. We use another union sign. Start up a hair beyond 5 with a parenthesis, because we don't want, this is not included. So it's in the parenthesis column, the open circle. And we keep going forever and ever and ever and ever, all the way out towards positive infinity. So we want all the numbers between 5 and positive infinity. Any questions on part 1 there? Let's look at part 2. And this may seem like a lot because it's the first time you're seeing this. This time, we take our denominator for function g and set it equal to 0 and see what happens. So we want to solve for x. Let's start by the opposite of addition, subtracting negative 81 from both sides. So we're just left with an x squared here. 81 minus 81 is 0. It's not 0 is not contributing on this side. And over here we have 0 minus 81, which is negative 81. Now, what's the problem with this negative 81? Well, you could look at this as the opposite of squaring is square rooting, but we need to put the plus or minus with one of the sides. We put it with this side. This negative right here is really, you can take that out and put negative 1 in there. What's the square root of negative 1? Anybody tell me what the square root of negative 1 is? The square root of negative 1 is I. It's the imaginary unit. We're working only in the real number system because we're working with graphing at this point. So we're working only in the real number system. So anything with an I in it, it's not real. Okay? Anything with the I in it is not real. It's complex, but not real. So the question is, so all of these numbers that we're getting here when we work this problem out are all complex numbers. We didn't find any real numbers that gave us a problem at all. We found all complex numbers which are not real. So none of the real numbers gave us a problem. So we need to include all of them. All of them. So we want everything from negative infinity to positive infinity. So if you come up with one of these and you get an I in it, and there you get, and you have, that means if it's very similar to this and you get an I in it, that means all your answer is all real numbers. Because anything with an I in it is not a real number. And we're only concerned about throwing out real numbers, not imaginary ones for this problem. So when you have all real numbers on a number line that you want to include, the way you do that in interval notation is parentheses, because we always use those around negative or positive infinity. And you go from negative infinity and comma, positive infinity. This comma means all numbers in between. Anybody have any questions on part 2 of that topic? So we're going to look at, for you visual learners, we're going to look at some graphs now. You may like this better. And anything you see that's written not in pencil is something you might want to copy down. So this particular topic, domain and range from the graph of a continuous function. So we just looked at domain algebraically. We're now going to look at domain graphically and range graphically. What is domain? Domain is a set of all x values for which a function makes sense. Range is a set of all y values for which a function makes sense. So let's just take a little scan of this. Define domain, collect all x coordinates on the x-axis. Define the range, collect all y coordinates, and see the next sheet. My notes for this should be in ALEKS. You can go to the main menu in ALEKS, those 3 horizontal bars up in the upper left. Click on those and then look for instructor resources. So first we want to find the domain of this graph right here. This graph, by the way, is the blue graph we're talking about. That's why I went this morning, I put that in. I thought it would be better visual, and you would understand better what we were looking at. Now we want all the x value of all these points. For the domain, we just want to find all the x coordinates of all those points and collect them together. So let's start. This graph had a colored in circle on it up here. So to get the x coordinate of that, the x coordinate of this, you just go down to -4, straight down. This point, if we wanted the ordered pair of this point, it would be -4, 2. So to get that -4, all we have to do is take this point and go straight down to the x-axis and get it. And then I colored it in down here on the x-axis. And then we just need to keep picking points up here until we get a good idea of how we're collecting all the x's and what we're going to be dealing with on the x-axis. So I pick another point, drop it straight down. You could put a colored in point there if you wish. Another point straight down. So the x coordinate of this point right here is -3. Another point, the x coordinate of they're not really lined up with the numbers. The x coordinate of this one is somewhere between -2 and -1. The x coordinate of this one is somewhere between -1 and 0. And you get the picture, right? You do this wherever you want. The idea is you want to do enough so you're 100% sure you're getting the correct answer. Now for this graph, at the origin, it switches. It now no longer lies above the x-axis, it lies below the x-axis. So we go the other direction to get the x-axis. We choose points and go up. This one was given as an open circle, so when we go up here, to get this 3 up here, we want to draw it as an open circle. Now this purple line is we're collecting all these x's, colored in circle all the way, all these points until we get to this open circle. So what is the domain? It's everything from -4 here, colored in. Now when we have a point colored in, we use a bracket. So it's bracket -4, all the numbers in between, to 3. Now the 3 is an open circle. That means we use a parenthesis around the 3. Any questions on how to find the domain from a graph like that or one similar? Let's look at range. To find the range, we collect all the y coordinates. For domain, D before R in the alphabet, X before Y in the alphabet. That's how I remember them. So to find the range, we want to collect all y coordinates. Let's see the next sheet. So this is what we want to look at. So we want to start on the x-axis, we start at -infinity. So on the y-axis, we want to start at -infinity, which is down here. We don't have any part of our graph at all until we get to right here. We were given an open circle at right there. Okay? So we're looking for the y coordinates of our blue graph. So we're going to take this open circle, and then we're going to trace it over to the y-axis, and it's at -3 over here. Might not be able to see that. So it's at -3. This guy right here is at -3. Did that not? It should go away. Okay, we've got the negative there. Okay, good. So that's at -3. Now, we go up here, we pick another point, go straight over, collect these, go straight over, collecting these, go straight over to get our y coordinate, go straight over. And then when we get on this side, we're going to go straight over this way. This is a colored in circle, so when we draw this one, we want to make sure it's colored in. And that one is at 2. So this guy up here is 2. Might be a little sloppy, but it's okay. I think you get the idea, right? Let's see if that works. Let's just toss that one. So this is at 2. I'm actually writing with my trackpad, and so sometimes I'm still getting used to it. You know, I didn't learn how to write overnight when I was a young girl, and I haven't learned it, you know, so this is what we're dealing with here. I'm doing pretty good with it, but it's just I've got to work on it some more. Okay, so our range, we start at the bottom. We go up. We get to -3. Are we going to have a parenthesis around that -3 or a bracket? Parenthesis or a bracket? What do you think? What do you think? So if open circle, do we have a parenthesis or a bracket? Okay, let's go back and look at how this works.
Is it parenthesis?
Yes, it is. It is definitely parenthesis. So when do we use parenthesis? When we have -infinity, +infinity, endpoint not included, or an open circle. So these purple notes are not in the Alex notes in the software. When do we use a bracket? Endpoint is included or colored in circle. There's really only 2 times. So if you remember these 2 times, then everything else is a parenthesis. So let's go back. Thank you for answering. So this is going to be parenthesis -3. All the way up, everything in between, until we get to 2. Now this is colored in, so it's not going to be a parenthesis, it's going to be a bracket. So this is parenthesis -3 all the way to 2 bracket. Do I not have the, maybe I don't know if I wrote that down, what the answer is anywhere. Yep, -3, parenthesis -3, all the way to 2 bracket. There we go. Looks good. So let's go on. Now what they're giving us is what we call a piecewise defined function. It's defined in pieces. So we have a piece here. If we're coming in from negative infinity, we have a piece here, right here. Take a break for a while, and then we have another piece of our graph. So we've got this graph right here. There's a break if we're going from left to right, and then we have another piece of our graph right here. So let's find the domain. So the domain, it's a set of all x's. And again, we want to trace that down or up or down to the x-axis. So here's our graph. We're up here. We know this is a colored in circle. We drop it straight down to the x-axis, and we get that point. Then we drop this, pick another point on our graph, drop it straight down, pick another point on our graph, drop it straight down, drop it straight down, and we drop this point straight down. It's going to give us this endpoint right here. Whoops. So now we've collected all of these. Now let's go to this other piece. So we now want to collect the x coordinates. So there's an open circle at this -1. It was already given to us on the graph. So if you go straight up to the x-axis to get the x coordinate, because we're finding the domain, we want to do an open circle there. Then we want to take something in here and draw it up to the x-axis to get that x coordinate. Then once we're on this side, we want to go down to get to the x-axis. Down, down, down. This is a colored in dot, so we're going to have a colored in dot right here. How do we use interval notation? We have a colored in, we come in from negative infinity. We have a colored in dot right here, which means we use a bracket at -3. Bracket at -3. All the numbers in between. And then we go all the way to -2, and that's colored in. And so we use a bracket. Use a parenthesis if you have an open circle, not a closed circle. Open circle. And then it takes a break. That's the reason for union. This really means or. So we want to be in this interval or this interval. We want our x's to be in this interval or this interval. So we go over here. The first x we're looking at here is at the origin at 0, but it's not included. So we put a parenthesis around 0. All the numbers in between, all of these guys in between, until we get to 2. That's colored in. So that means we colored in, we use a bracket for. So we have a bracket around 2. Any questions on finding the domain of a piecewise defined function? And you will see up here, write the domain and range of G as intervals or unions of intervals. And that's the reason for this U here, when you take a break in between. For range, see next sheet. I want to just check back to see. Yeah, I think I separated this out. I didn't want the graph to get so cluttered. So this one, there's actually 2 graphs that were given to us. Two pieces that were given to us, if you will. I should have put the blue markings on those. Some other markings so we can take a look and see what color we've got here. So we're really talking about these guys right here. Okay, that should clear in a bit. And then it looks like right here. Okay, we're talking about those blue graphs. Let me see if I can get that to clear. Okay, cool. Okay, so if you have a problem like this, I would look at all different parts of the graph and trace them over to, so you've got two graphs here. I would take each one of those two graphs and trace it over to the y-axis just to make sure you collect all the y's you need. So this one, range, remember, is all the y's. So we want to go over to the y-axis. So I'm going to start here. This is colored in, go straight over here. Now really I should have put a colored in dot here. Tracing all these guys over the y-axis. I mean, typically we do it from the bottom up, I suppose. Trace this over, 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 trace this over to the y-axis, collecting all the different y coordinates. Then we want to do it on this side. This is an open circle right here. Okay? So it's given as an open circle, so we want to make sure we keep it as an open circle to remind us, because we don't want to write our interval notation incorrectly. So we're going to take on the graph, go straight over to the y-axis to collect all the y coordinates. This is colored in, so this one is going to be colored in. So this, when we write the domain or range, we're writing smallest to largest. So the smallest y value under consideration is -1. It's open, so we have a parenthesis around -1. All the numbers in between until we get to 5. That's colored in, so we want a bracket around 5. Any questions on this particular topic? Finding domain and range from the graph. Graphs can speak 1,000 words. There's a lot to be said for a graph. Now, I didn't get time to do this topic in my last class, so I think I might skip it for this class too, just to keep you all on the same page. But this is the last topic in this objective. Let's look at this first. This one is easier to deal with, and I think a good way to finish up the class. You've all been very attentive, and I'm glad that you're giving me feedback. So this topic is finding local maxima and minima of a function given the graph. Now it says local. Local means close by. These circles here are what we call neighborhoods. Honestly, we call them neighborhoods in math. So these circles are what we call neighborhoods. This neighborhood could be really, really tiny. We could be very, very, very local to that point right there. Very, very local. So it can be in an ever so small neighborhood, and it still would be a high point in that small neighborhood. So local maximum points are highest points in a small region of the graph. So if you can draw a circle around that region, it could be a really, really small circle. I just didn't want to do that because I wanted you all to be able to see what we were talking about. It could be ever so small. But remember, circles are the outside part. They're not the inside part at all. So you can make this really small. And still, that point right there would be the highest point in that neighborhood, or inside that circle, if you will. And then we have another one over here. You can draw a really small circle, and that dot there is still the highest point. So that's what we're talking about here. In this particular problem, use the graph to find the following. If there is more than one answer, separate them with commas. All local maximum values of f. Now, f is acting like the y. X is what acts like x. F, G, H, they're acting like y's. Okay, so what we're talking about here, we want the y coordinates for this part A. And Alex may may mix these ups in different problems. They may, as the first step the first step here is to find the y's, but in the next problem it may be to find the x's. So I want to pay pretty close attention to that. So what are the x's? What are the y's? What are the y coordinates of these points here? So we want to find the y's first. What are the y coordinates of these points? To get the y coordinate of this point, we trace it straight over to the y-axis and get 3 up here. Get the y coordinate of this point, trace it straight over to the y-axis here and get it 3. So the answer, 3. And we're looking for all local maximum values. I maybe didn't make that clear. Maximum values are high points. We're looking for all maximum values of f. So that would be 3 because f is acting as the y coordinate. There's only one of them. We happen to have 2 peaks here. Well, each of those 2 peaks has exactly the same y value, so we only list it once. Now, all values at which f has a local maximum. F is the y. They're asking us all values at which y. So that means they're wanting the x's. What are the x's? So we go to the point to get the x coordinate, we go straight down to the x-axis, -4. Check right here. What about the x for this one? Because it says all values at which f has a local maximum. And the values at which f has a local maximum are what? What's the x coordinate with this? What's the x coordinate of this one? Straight down to the x-axis? It's 2. -4 and 2. So just remember, all local maximum values of f, that's what I'd be looking out for, or g or h, that means the y's. The other one, whether it's a or b, who knows, the other one is going to be the x's that you're looking for. Now, the other way they can mix up this problem is they're looking for local minimum values of f. Here, this guy right here is a local minimum value because in a small neighborhood around this point, that point is this lowest point, not the highest one, the lowest one. So that's a local minimum value of f. We could answer that question, or we could answer the question, all values at which f has a local minimum. The local minimum value of f would be the y value. To get the y value, you would go straight over to the y-axis, and that looks like it would be at -3. All values at which f has a local minimum, those would be the x values. The x coordinate would be straight up -1. So those are what you can, some twists on this particular problem that you may see. So let me come back up and give you a few minutes to ask some questions, and we'll cover that last topic in this objective on Thursday, and then we'll talk about the test. Anybody have any questions that they want to address? Have any questions that you want to talk about today or ask about? Anything we did today? We can talk about do you have any questions you'd like to get answered about the test? You can talk about that. Anybody have any questions? Okay, let me make sure that I take attendance again because I want to make sure everybody who is here gets credit. I took it earlier just in case, but I want to take it now to make sure I'm giving everyone credit that's here. Okay, got your attendance. So you feel free to leave. I don't want to cram in another problem. Feel free to leave, and you're welcome to stick around and ask questions. I actually have virtual office hours now But if we stay too long, we'll have to hop into another conference using a different link. So bye for now. Take care. Feel free to stay around for a little bit and ask some questions. I think my office hours start at 2 in a different Teams meeting. Anybody have a question? Ms. Chavez, do you have a question? Okay, I'm going to leave the meeting now.